And we stop. Okay, so we're going to start with physics today. And we're going to focus on classical physics, right? So, good morning. We're going to learn about Newtonian physics and the laws of motion. So, Newton is also the father of gravity. Okay, so he unified gravity on Earth and in the heaven. And he based his work on the work of Galileo. So, we talk about him as well. So, that will be kinematics and dynamics. So let's keep that and let's start. Okay, so one thing which is very important in physics is the units of physical quantities. So you really need to know the units. So here I have shared with you an equation sheet. For example, if you are taking the MCAT, who is taking the MCAT, by the way? 1, 2, you see, you should get together, make like a WhatsApp group. So the idea will be to study together the MCAT as we go along. So we're going to start with kinematics. You should start going over kinematics problem in the MCAT. Okay, so that's a parenthesis. But here you see all the physical quantities that we're going to work with. Okay, so kinematics, for example, is not kinematics, kinetic energy is a physical quantity. The unit will be joule. Power, you already know power, right? The unit is watt. Okay, very good. And then force, the unit will be Newton. So all these are called physical quantities. Okay. So here for international system, the units that we're going to use will be meters for distance. Okay, so we are not using miles or yard, that they don't make sense. No, we are in a power of 10 system. So meters will be for distance. For the mass, it will be kilogram. So pound, for example, is not a unit of mass, it's actually a unit of force. And it's only used in the British system. And then time, it's going to be in second, and so forth and so on. So why is it so important to know units? Because sometimes when you have a physical quantity like speed, and you know the unit, which is meter per second, so you can kind of guess the equation. So meter is for what? Distance. Second is for time. So speed is distance over time. So when you have a slash, that means per unit of. So per unit of second in that case. Okay, so acceleration. So we're going to learn about acceleration, which is sometimes not intuitive. So here you have meter per second. So meter per second is for speed. Second is for time, right? So meter per second means how fast something is getting faster. So it's speed, or the change in speed over the change in time. So that works also for chemistry. Sometimes if you forget the equation, you can refer to the unit. Sometimes it can be very useful. So distance is in meters. Okay, and then you have subunits. So for example, Newton is the unit for force, but Newton is really kilogram, which stands for what? Mass. Okay, meter per second is for acceleration. So you see, force is mass times acceleration. So instead of writing for acceleration, instead of writing per second, they use s to the minus 2. Okay, they use a subscript. It's easier, but it means the same thing. So s to the minus 2 means per second. S to the minus 1 means per second. Okay? It's just an introduction. And then what else we have? Watt. Okay? And watt means joules per second. And joule is the energy for hour. It's the unit for energy. Okay? And second is the energy, is the unit for time. So it means that power is energy divided by time per unit time. So when you divide by the time, it means it's a rate. So it means how fast. So how fast energy is being consumed. So for example, if you buy a microwave, for example, it will tell you how much energy it's consuming per second, okay, or delivered. How much energy is delivered. If you go back to energy, and energy can be work, we're going to see that in physics, work is a physical quantity, and the energy in transfer, like heat, energy in transfer, the unit is joule. But joule is really Newton meter. So it means if you want to find the energy that you are producing, for example, when you are pushing a car, pushing something, a cart, for example, then you multiply what by what? Newton stands for force times distance. So force times distance is the energy. Okay, so if I want to know how much energy I am delivering to a cart that can hold, right, I will multiply my push by the distance it moved. So how much energy is being transferred and turned into kinetic energy, for example. So make sure you pay attention to the unit. Another example, which is used a lot in chemistry or thermodynamics, is the pressure, okay, PA. So pressure, Pascal was French, so I know I say it right. Pascal, unit is Newton per square meters. So what does it mean? Newton stands for force, square meters is the unit for. I cannot, I'm area. Thank you. Speak out, right? And it's good. It's relieving all the stress, right? You have to speak out. Plus, I'm old, ears are not working very well. So, Newton per unit area. Per unit area, because there is a slash. So, for example, the atmosphere pressure, for example, will be 15 pounds. So 15 pounds per square inches. So if you take a square inch, right, and you measure the weight of the air just above it going to space, it's going to be 15 pounds. Okay, so usually we measure the gauge above that 15 pounds, the atmospheric pressure. So for example, if you have a car, you're going to read 33 pounds per square inches. And then your car will complain that you are below the 33, for example. That means the pressure inside the tires are 33 pounds per square inches above the atmospheric pressure. Okay, so physics is very, very useful. Now the cars are all digital, right? They tell us, okay, it's below 33, you have to inflate that. Okay, so I'm not going to review the math like I'm reviewing for my algebra-based class because it's a more advanced class. But if you need some help here, I have made 2 PDF. Okay, so one is to go over scientific notation, one is to go over proportion, how to solve proportion, how to do conversion, and you will find the tutorials in my Dropbox. Okay, so you open, I think it's called homework or assignment, and then you go to Unit 1 Math, and you have tutorials if you need extra help. So it depends on students, right? So now I'm gonna just skim through. It's not for you to do and to give it back to me. Okay, I have 110 students. I can't. But if you need help, you can come before the class or after the class. Okay, so I can help you if there is something you're not sure about. So just to make sure you know how to use your TI. So that's why I recommend the TI, because that's the one I have on my computer, but any scientific calculator will do it as long as you know how to do it, to use it. So for example, here, if you want to go very quick with the TI, so you take that number, I think it's the Avogadro number, so 6.022, and then you go second comma. Here, that will be your power of 10, and then 23. If you do it this way, you go much faster. Okay, so you can use this as a power of 10. If you have, so scientific notation, you need a number between 1 and 10, not including 10, so 1 and 9. And then you have your power of 10, and this will be the exponent. So when you multiply scientific notation, okay, you take a parenthesis here, and you're going to do, for example, I don't know, 5 times 10 to the 7, and then you don't have to do multiply, you just open your parentheses here, and you can go 8 times 10 times 10 times 10 to the 6, close the parentheses, and enter. So that would be 4 times 10 to the 14. One thing I've seen with students, the typical mistake, like if you have 10 to the 5 or 10 to the 5th, you want to make sure to do it this way. So second comma, that will be your power of 10, 5. Okay, so that will be 10 to the 5, 100,000. Okay, if the exponent is negative, that means your number is smaller than 1. So for example, if you have 3 times 10 to the negative, so you have to use that negative 2 here, that will be 0.03. Okay? If you divide by 100 here, 1 over 100, that will be 10 to the negative 2, or 0.01. Okay, so just a quick review. I never know where you are at, but if you need extra help, okay, you can practice here, and I went over that in my tutorial. So for example, if you need to divide, okay, very convenient. Also, when you divide, you want to make sure to frame the denominator. Always. You always frame the denominator, because if you don't, you have pandas. And that will say you always divide and multiply before you do anything else, and you always have mistakes. So I always see that with students. So you always framed your denominator. So for example, you do 10 to the 8. Here you divide, you open the parentheses, and then you can do 6 times 800 times, I don't know, 8 times 10 to the negative 6, and you close your parentheses. So make sure you always frame the denominator. Even if it's a calculus-based class, I always see that mistake. You will have the answer here. Yes?
I get it, because if not, it would write it left to right and then first before actually finishing all the operations that the denominator has to do, right?
Exactly.
Yeah.
Exactly. So it's a typical mistake. So always frame the denominator. So this is called standard notation. So if you want to go to scientific notation, you're going to skip back from the decimal point. So 1, 2, 3, 4, 5. So 2.2 times 10 to the 5. I'm not going to bother you with significant values that you will do that for chemistry. So chemistry, they will insist on that. Is that clear? Okay, so if you're not sure again, it's going to be heavy in scientific notation, so make sure you master that. Okay, and then you have the metric prefixes that you should know, also very useful for biology or chemistry or engineering. So the trick is, if you see kilo, for example, you have to substitute kilo by 10 to the third. So, for example, if you have 2 kilometers, so kilometer is not a unit for distance, we want meters. So 2 kilometers will be 2 times 10 to the third meters. So it's like a sticker. Okay, you remove the sticker kilometer and you substitute by 10 to the third. Kilogram is fine because kilogram is the unit for mass. Okay, for another example in chemistry, if you have 5 milliliter, milliliter stands for 10 to the negative 3. So that will be 5 times 10 to the negative 3 liters. 5 millimeters, 5 times 10 to the negative 3 meters. Okay, nano means 10 to the negative 9. So 1 billionth, which is 0.00000000001. Okay, so for example, 1 billionth second. So for example, light will go 1 foot in 1 billionth of a second. So it's really fast, but it's finite. Okay? So if I see someone sitting in the back a few feet from me, it will take time for light to reach me. So if he was really fast, he can disappear and I will not know it, right? If he was able to go very, very fast in a billionth of a second. So I think he's here, but I'm not sure about it, right? Because it takes a few billionth of a second to reach me. Okay, that's a tangent. Micro, 10 to the negative 6, right? So micrometers, you replace micro by 10 to the negative 6. And then in computers, for example, you are familiar with that, mega, 10 to the 6, right? So for example, megawatt hour. So watt hour is a unit of energy because you multiply power by time. Mega means a million. So a million watt hour. So I don't know, in 2022, energy was very expensive. I don't know why I took that example. It was 295 euros per megawatt hour, so 10 to the 6. And then you have giga, so that will be 10 to the 9, right? So 41 gigabytes. Okay, and then you have tera. So tera is 10 to the 12. So, for example, you have a large hadron collider between Switzerland and France, and they smash atoms, and the energy required for that is totally insane. It's huge, so it will be about 6.5 tera electron volt. Huge amount of energy. Electron volt is another unit of energy. Okay? So I'm just an introduction here. Okay, so you need also to know how to solve proportion, to do conversion, for example. So 1 kilometer is 1,000 meters. And you have some examples here. So let's see. One thing you can remember. So one thing I always remember. So miles, that's what we use here. So this is the British system. No one else is using the British system except the US and another, I don't know, country somewhere in the world, a small country is still using the British system. The British gave up on the British system, even though they developed the British system, but we are still using the British system, right? Not the metric system. So you need to know how to go from one to the other one. You know, the British system was developed, like, for example, when you say 1 foot, it was based on the foot of a king. I don't know which king. 1 inch was based on the inch, right? So it's kind of obsolete. So nevertheless, we are still using the British system. So the way you do convert from kilometer to miles, it's easy to remember. If you like to run, if you have a running app, they always tell you, oh, you have to go for 5K. 5K is about 3 miles. 10K is about 6 miles. So it's easy to remember. Okay, so 10 kilometers is about 6 miles, 5 kilometers is about 3 miles. And then you can solve the proportion. Another thing to remember is that kilogram is a unit for mass. In the British system, the unit for mass, so mass is how much stuff. It depends on how many molecules inside you. So if you go to the moon, you will have the same mass. But pound is a unit for weight in the British system. So it means how strongly gravity is pulling on you. So for some strange reason, if you go to Europe, you step on the bathroom scale, you're going to read your mass in kilograms. But in the US, you're going to read your weight in pounds. So one thing to remember is that 1 kilogram is about 2.2 pounds, even though they are not measuring the same thing. Okay, this is for weight and this is for mass. They are proportional to each other, but it's not the same physical quantity. So if you go to Europe and you see that you have 80 kilo on the bathroom scale, you multiply by 2, it's about 160 pounds in the US. So you know if you have lost weight. Usually when you go to Europe, you lose weight. And you go back to the US, you put on weight. I don't know. Another thing to remember, okay, is that 1 meter per second is about 2.2 miles per hour. You see, you have this 2.2. 1 kilogram is 2.2 pounds. 1 meter per second is 2.2 miles per hour. Okay. Now I have also another PDF for you here where I go over conversion. So I'm not going to do it, but it's in a tutorial. Okay, so that here is something very nice to remember. That you can memorize. 1 year is about pi times 10 to the 7 second. Okay, so it's about 3.14 10 to the second 7 seconds, right? So 1 year, okay, something can be useful. This is useful to remember. So 1 year will be 365 days. Agree? Depends. About. And then you multiply by 24 hours. Agree? Okay. And then multiply by 60 for the minutes. And then 60 for the second. And that's what you get. So 1, 2, 3, 4, 5, 6, 7. So it's about pi. Okay. So when you're going to use that, you can just say with your calculator, 1 year is, you go second year, pi times 10 to the 7. It's an approximation, but that's good enough. Okay, so 3 times 10 to the second. So sometimes it's very useful to remember that. What else? Are you with me? So you need to know how to do those conversions. And again, you have a tutorial if you need if you take this class because the other class is totally full, for example. Okay, so you need to remember how to use. If you are a biology major, you don't need to take this class. You can take, but it's good. It's nice. It's good on your transcript. So, for example, you will say if you are doing scaling, so 5 centimeter on a paper is 10 miles. And let's say you want to do 3 centimeters. I'm going to put a question mark. And remember how to solve proportion. You do cross multiply. You cannot do cross multiply because you don't know. So you cross multiply, you divide, and you get x. Cross multiply, divide, get x. So that will be 10 times 3, yes, which is 6. Okay, that works all the time. You can do it in your head. Some people can do it in your head. Otherwise, this will work all the time. So it's called solving a proportion. Okay, so here will be centimeters, here will be miles. You cross, multiply, divide, get x, and you can do it in one strike with your TI. Okay, you don't write it on the paper, write on your TI. 10 times 3 divided by 5. If you have scientific notation, make sure to frame the denominator because of pandas. Okay, are we good? Any question? Okay, and for you have all those. So 5 centimeter will be 0.1 millimeters, and I think in chemistry you're going to go over all those conversion. 1 hour is 3600 seconds. Also worth it to remember. And again, if you need a refresher, the level in one class is very. It's a lot of levels. So make sure that if you need practice, you will find a tutorial in my Dropbox, okay? And since you don't have a lot of homework for next week, you can do that. You should also review trig, cosine and sine and tangent, scientific notation, and proportions. And then there will be a little, a small layer of calculus. Okay, are you surviving? It's good. So again, this is the British system here, and that will be the metric system, and we are using the metric system. Even the British don't use the metric system anymore. So here you have, I think it comes from your book, okay, some examples of order of magnitude. So a proton, let's say if you take a hydrogen atom, let's say hydrogen atom has just one proton. Do you agree? Okay. So that will be the size of the atom, 10 to the negative 10. So that will be the atom. The proton is the nucleus. So between 10 to the negative 15 and 10 to the negative 10, what's the factor? How do you go from one to the other one? You multiply by 100,000, right? Okay, 15 minus 10 is 5, so 100,000. So that means the size of a hydrogen atom, where the electron is 100,000 larger than the size of the nucleus. 100,000 larger. So if you take a nucleus, the size of I don't know, a rice, for example, little piece of dust here, the electron will be around BBC. You know, this is how much vacuum do you have inside the atoms. Isn't that interesting? It's 100,000 factor. So let me ask you something. If we don't see the emptiness here, it's because our eyes are not electronic microscopes. Okay, we have a very bad resolution. But since there is so much emptiness, how come I don't get through the wall? I should be able to go through the wall because of all this emptiness. It's like I'm being repelled by the wall. Any idea why? Atoms are made of atoms on the outside, electrons. So I have electrons here and I have
electrons there, charge.
Exactly. So you think you are touching the wall, but you are not really touching the wall because the electrons are repelling each other. But it's a lot of emptiness here. Okay, so a virus is very small. Can you turn that into micrometer? 1 micrometer is 10 to the negative 6. And here you have 10 to the negative 7. So how many 10 to the negative 6 will fit in 10 to the negative 7? 6 and 7. So yes, so it will be what? What's the number? Okay, so 10 or so 10 to the negative 7. Okay, and I want to turn that in micrometers. Micrometers. Okay, so 10 to the negative 7. 1 micrometers, remember it's what? 10 to the negative 6. So that will be 0.1. 10 to the negative 7 is 0.1 micrometer. So it means it's really, 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 really small, right? Going through everything. So 0.1 micrometer. So if you are not sure how to convert, then you divide, because then you're going to say how many micrometers will fit into 10 to the negative 7. Remember, division means when you divide how many fit in. So if you want to convert to kilometers, for example, or to to kilometers, you will divide by 1,000. From meter to kilometers. Okay, and what else? So here you have the size of an electron. No, that's the mass. The mass of an electron and the mass of a proton. How do you go from one to the other one? 27 to 30? 3. So the factor is 1 with 3 zeros. 1,000. Okay, so it means the electron has a mass 1,000 times less than the proton. Actually, it's 2,000, but it's order of magnitude. So that's why in the periodic table, when you have atomic mass, they don't care about the electron because it's 1,000 times less for each proton. So they just take into account the number of protons. Okay? The virus, it's very small. The Earth 10 to the 24 kilograms, right? Just to give you an idea. Okay, let's do an exercise here just to make sure you know how to do it. 1 nanosecond is 10 to the negative 9. So if you have 10 to the negative 10, how many nanoseconds? 0.1. Okay, you do 10 to the negative 10, divide by, open the parentheses, 10 to the negative 9, and you get 0.1. Okay, you see how it works? If you want 10 to the negative 15 in nanoseconds, you will do 10 to the negative 15 divided by 10 to the negative 9. Okay, so how much is fitting into? Okay, the age of the Earth, and so forth, and so on. So 10 to the negative 6 is 1 microsecond. 10 to the negative 4 in microsecond. How many microseconds in 10 to the negative 4? Yes, so 10 to the negative 4 divided by 10 to the negative 6, what do you get? 100. 100 microseconds. So let's look at human. Here, 10 to the 9, and you want to know how many years. And 1 year, so 10 to the 9 seconds, right? 1 year is how many seconds, we said? Very good. Pi times 10 to the 7. So forget about pi because we are doing approximation. 10 to the 9 divided by 10 to the 7 is 100. Okay, if you are very healthy and lucky, 100 years. Okay, so let's do that. Try to help each other. So 1 light year is a distance. So 1 light year is a distance traveled in 1 year. Okay, and the speed of light is 300,000 kilometers per second. So 300,000 kilometers per second. And you already know that 1 year is pi times 10 to the 7. So you want to know how many kilometers. Okay, so again, light year is the distance traveled by the light in 1 year. So you want to know that in kilometers. So let me know if you get it, so you can do a proportion. 3, there is nothing wrong to do your proportion in 1 second. And 1 year is about 3 times 10 to the 7 second. And you put a question mark. Do you agree? So you cross multiply, divide, get x. So you can do that with your TI or in your head. And you want scientific notation. 3 times 3 is 9. And then you have 10 to the 5 and 10 to the 7. So 7 plus 5 is 12. Now, I can do it with the TI, okay? If you can do it, you can do 300, 1, 2, 3. Okay, you multiply by, I like parentheses, so I make sure I'm not doing any mistake. Boom, and boom. 9 times 10 to the 12. Any question? Yes. Oh, I 3 and 3. You multiply. Oh, you take your TI. Okay? Yes.
Isn't that into trillion?
Yes, very good. Trillion. Exactly. So if we want to use prefix, because this is annoying to carry around, so we're going to say 9 trillion kilometer. Okay. You could do the computation that in one foot will be 1 billionth of a second. So the light will travel 1 foot in 10 to the negative 9 seconds. Or in kilometers will be 9 trillion kilometers. Okay? Yes.
And speed of light is 3 multiplied 10 power of 8 or power of 7.
So 3 times 10 to the 5. This one, 300,000?
And the other one is like 3 times 10 to the
To 7. So 1 year, something to remember, 1 year is about 3 times 10 to the 7 second. Pi. It's like pi. It's actually 3.15 times 10 to the 7. But most of the time, because you have multiple choices, 3 is fine. And one day is 3600 seconds. Yes.
It says the speed of light is 3 times 10 to the 8.
Oh, I did I do a mistake? Oh no. Why? Okay, good question. Why? Can you tell me why? Because what? Yes. Because this is meters and I convert that to kilometers. Okay? So 1 kilometers is 1,000 meters.
That's
Okay. So for example, 1 kilo is 10 to the 3, right? So 3 times 10 to the 8 meters. You divide by 10 to the 3. So to know how many kilo goes into it. So that will be 3 times 10 to the 5 kilometers.
You had 3 times 10 to the 8 for kilometers.
Yeah. Okay. I was almost in panic. No, I don't know the speed of light. That's very bad. Well, it's good. Okay, so kilo, you remember, it's like a sticker. When you have a kilo, you can substitute it by 10 to the 3. So 1, 2, 3, 4, 5, 6, 7, 8. Everyone is with me? Okay, so let's convert that to miles. So let's do the conversion to miles. 9 trillion or 9 times 10 to the 12 kilometer, convert that to miles. And remember, if you like to do running, if you run, you know that 3 miles is about 5 kilometer. It's the 5K. Any running app that says, oh, you have to do 5K. Oh, that's not enough. Do 10K. Oh, that's not enough. Do 15K. It's never enough. But 3 miles is 5K. So here you have 9 times 10 to the 12K. What's going to be in miles? So you use 6, yes. You use your TI or yes, you use your head. So the answer is 6, right? So you cross multiply. So 9 times 3 times 10 to the 12 divided by 5, which is 27 divided by 5, which is about 30 divided by 5, which is 6 times 10 to the 12 miles. So if this is confusing, okay, don't worry, you take your TI. Okay, you take your TI, you cross multiply. So 3 times 9 times 10 to the 12. Okay, you cross multiply, except I did a mistake. 3 times 9 times 10 to the 12, and you divide by, cross multiply, divide by 5, and it's about 6. That should be 3.1. So I'm rounding.
You should be rounding down.
Yeah, but it's about. Because here it's not really 3, it's 3.1. So I'm just showing you here how you can do it in your head, otherwise you take your calculator. So of course, if you take the calculator, you will get a better answer. But here it should be 3.1 miles. Yes.
Are secrets important in this class or no?
The what? No. That's for chemistry. Significant figures is a headache. Physics is already hard as it is. Do that when you are an engineer or a physics major. Okay, so by the way, you see what I have done that? I did it by hand. You don't have to do it for this class because you have your calculator. But if you are taking the MCAT or some exam, for example, they don't let you use the calculator. For example, for the MCAT, you cannot use the calculator. So they expect you to do things like this. But for this class, do not worry, you just do cross, multiply, divide. Okay? Okay, and then maybe in high school, they taught you to do it this way, you can do it that way, and they will teach you that in chemistry. I'm sure when you are reviewing the math, you do it step by step, you cross, 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 and you have the right answer here. Okay, skipping, skipping, skipping. Okay, boom, we are done. Okay, let's start. Kinematics. So I'm trying not to take anything for granted. If you have any question, you can ask, raise your hand. And if you are too shy, you can see me at the end. Before the class is better, because after this class, I think there is someone else. But not right away, so I still have time after the class. So you have two branches in what we're going to study this year. You have kinematics that will only study motion. So you will need physical quantities such as acceleration, velocity, displacement, time. And then we will go to dynamics that will explain why motion happens in the first place. So now we start with kinematics. So kinematics in one dimension, which is easy, quite easy. So in those cases, we're going to define the number line. You are all familiar with the number line. But now that number line will have direction. So if it's moving in this direction, which is a positive x, then that means the displacement will be positive or the velocity will be positive. In this direction, it's going to be the negative x. So if you are moving in this direction to the left, in that case, the velocity will be negative. So we're going to introduce some direction. Positive this way, negative that way. And then we're going to introduce also the time. Time will be a physical quantity. And then you will decide what's the initial position. So initial position, x. So the position is x on the number line, or y if you go up or down. Okay. So the initial position will be defined as the position the object has when you start a stopwatch. So in your mind, you have to imagine like a stopwatch. You start your stopwatch, initial position will be 25. You keep moving, you don't have to stop, but you can decide here that you're going to stop the stopwatch, and that will be your final position. Okay? And then we're going to define another physical quantity. So I'm just introducing, and we call that the displacement. The definition of the displacement will be the final position minus the initial position. So in that case, the displacement is 25 to 50. It's going to be 25 meters. It's positive, meaning it's going to the right. However, if you decide to go from 50 to 25, you start your stopwatch at 50, position 50, and you stop at 25. What's going to be the displacement? What's negative 25? So now your displacement is going to be negative. So we're going to see that displacement is like a vector, so we define vector, but it's an arrow that is where you connect the initial position to the final position. So if this is the final position, this is a initial position, final position, you see it's pointing to the right, so it's going to be positive. if this is your initial position and this is the final position, it's going to be negative 25 and it's pointing to the left. Okay, so we'll define that. But displacement is a physical quantity. It can be positive or it could be negative. Okay, we define another physical quantity that makes more sense in everyday life, which is the distance. Distance means it doesn't matter if you go to the right or to the left. What matters is just the distance, the length. Okay, so if you go from here to there, the distance is 25. If you go from 50 to 25, the distance is 25. Okay, we'll talk about that. We're going to talk about velocity, okay, acceleration. If the velocity does not change with time, so in that case we can talk about the speed. It means what? The speed is constant, very good. So it means you have your stopwatch. So you have the same time interval here between the red dot and the distance covered is the same. So that will be a constant speed. There is no acceleration. We will learn that if there is no acceleration, there is no force. Because acceleration is just force per unit mass. So in that case, what's going to happen? Is the speed constant? No, right? The speed is increasing. Because every second, the car, so this is 1 second elapsed, the car is moving farther. What about, so there is an acceleration, there is a force, there is the gas that you push. What about in that case? There is an acceleration, but decelerating, right? You are slowing down. So the velocity will change with time. Okay, so just an introduction to kinematics. So here I have something to help you out. These are the physical quantities that we're going to work with. So on the number line, x will be the position. It could be positive or negative. And then you're going to have the initial position and the final position. We're going to define the displacement. Displacement will be a delta. Delta means the change, means final minus initial. So your displacement will be your final position minus the initial position. We're going to define velocity. We're going to see velocity can be positive if you are moving to the right, negative if you are moving to the left. You can have some initial velocity to begin with when you start your stopwatch. And then we define the final velocity when you stop your stopwatch. Okay, acceleration, we talk about acceleration can be negative or positive depending on the force acting on the object. And then distance is just like a length, right? We'll talk about average velocity, time will be in second, and that will be a summary of the equations that we're going to use. So just an introduction is just a summary, right? So for example, I don't have okay, I'm just sticking to my slides because I keep shuffling them around. That's not good. Okay, let's something easy here. The first definition, average speed is just the distance over the time elapsed. Right? That's easy. Okay, the unit is meter per second. So it's not miles per hour, it's meter per second. So 1 meter per second is about 2 miles per hour. So meter per second. So let's do that. This one is easy. Yeah, okay, so when we get to problems like this one, I encourage you to talk to each other. Okay, you can help each other out. I don't want to take too much time because there is so much to cover, but you can try. So be careful to have the right units, right? So first you identify the physical quantity. You see that this is time. Hours, you are not happy with it because you want second, right? So that will be depending on the problem, but here you have second, so you want second here. So 1 hour, so it's 90. 1 hour in seconds, so it is going to be 3600
There.
plus 1800, right? Is that right? 1 hour is 1.5 times 3600, and that will be the speed. So what do you get? You want the distance. Uh, 2.2, you can do it this way, 2.2 meters for 1 second. So if you have 3600 times 1.5 question mark, so you cross multiply divide and you get 199.8 meters. No. So 2. Do you get that? You multiply by 1.5, right? 1 hour is 3600 seconds. So that's going to be 3600 times 1.5. That will be in meters. That will be in meters. So how much is that in kilometers? Yes. So it's going to be this, right? About 12 kilometers.
11.9.
Yes. 11.9. Do you all agree? Right? It's easy, right? You have to know by heart that 1 hour is 3600 seconds. Okay, so 1.5 hours, it's going to be 3600 times 1.5. Okay, you can convert that first and then you do this one, you cross multiply divide. If you are confused, you use that equation. Same thing, right? Speed, so 2.22 equals the distance, that's your x, over the time, which is 3600 times 1.5. And then you put a leg here, because otherwise you cannot stand. I used to teach math. That's why. So you put a leg, so you cross, multiply, divide, get x. Agree? I see rolling eyes, so I'm a little bit worried. If you need help, you can see me at the end. Yes? I can slow down. Okay, let's see. Oh, by the way, remember those problems here? I have tutorials in my Dropbox where I go over them, each one of them, step by step. It's somewhere, I forgot where, but it's somewhere in the Dropbox. Let's try to do number 4. This is miles per hour. Miles per hour. You can help each other. So the time elapsed here will be
Half. An hour and a half.
an hour and a half. So again, it will be, oh, we stay in hour. And
Distance.
this is the distance. Exactly. So we keep that. Okay, you're not changing. So the speed, by definition, is the distance divided by the time. So it's going to be the distance 4.6 divided by 1.5, which is about
3.
3 miles per hour. Okay? And then they want to go into meter per second. Let's go to kilometer per second first. What did I tell you last time? I say, look back in the slide. 1 meter per second, is it about 2.2 miles per hour? Okay, so that's easier to remember that, so you don't have to do all those conversions. So 1 meter per second is about 2.2 miles per hour. And you have 3 miles per hour here. Which is that right? So 3, 2.2, which is about 1.5 meter per second. About.
Closer to 1.4.
Right? Or 1.4.
Because the actual results like 1.6.
1.36. So where is my conversion? Oh, I closed it. But 1 meter per second is about 2.2 miles per hour. Is that clear? At least this is the average. So I'm going to put a bar here to say that means average. This is the average speed, will be the distance divided by the time. The distance here is in miles, time is in hour, so that will be miles per hour. And then if you do the conversion, you do cross, multiply, divide. If you want approximation, because it's multiple choices, so it will be, you can do it about 3 divided by 2, which is about 1.5, even though it's really 1.36. Are you with me? Okay, let's do number 5, so we can help each other. And again, you have a tutorial in my Dropbox somewhere. So average speed, I'm going to put a S with a bar. So that will be the average speed, is the distance divided by the time. So the time has to be in second, and the distance has to be in meters. So second 30 is good. This is not good. So you have to convert. Yeah, 210, right? Second. Which is about a good 7 meter per second. Because I use multiple choices, so it depends on the professor, but I use multiple choices, so you will see if it's a 7 or 3, they're gonna be apart. You can put 7, yes. Otherwise, you have to think about the significant values. So here we have 1, 2 significant values, so you can keep 2, 7.2. Okay, is that easy for everyone? 1 mile is about 1609 meters, or 1.6 kilometer. Okay. Talking about vectors versus scalar. Okay, so let's say you go. I don't know why I found a cockroach. I don't know why it's a cockroach. Don't ask me. I forgot why. So let's say you have a cockroach here. It takes a walk like this, right? It's starting at point A and it's going to end at point B. So A is the starting point and B is the stopping point, right? So we are just considering the motion between A and B. And it's going this way, that way, that way, this way, that way. If I measure with a meter tape, like using a surveyor wheel, for example, if I measure this length here, that's what in physics we call the distance. There is no direction. It's just a magnitude and a unit. So, for example, I could say, I don't know, 30 centimeter. So the distance is 30 centimeters because I was able to measure that distance here with a tiny, itsy bitsy surveyor wheel, a small one like this. So that will be the distance. Now, if you connect point A to point B with an arrow, okay, so an arrow here has a tail and a head. So I go from A to B. That quantity here, that object, we call that an object, so that object is called a vector. And this is called the vector displacement. Okay, that vector displacement has a magnitude, 23 centimeter, or 23, a unit, centimeter, but also a direction. So a vector is an object, so it's a mathematical object with how much a magnitude, of what unit, which way a direction, how much of what which way. So this is in 2 dimensions. So we're not going to worry yet about 2 dimensions, but the idea is that a vector has a magnitude, a unit, and a displacement, and you connect the starting point here to the last point. This object here, the length, is called a scalar. A scalar has just a magnitude and a unit. So if you say, I'm going 30 miles away from BBC, you don't exactly where you are ending, right? It could be north, west, south, we don't know. But if you say, I'm going 30 miles northwest, then it's a vector. You know exactly which way you are going. Or you can say 30 miles at 20 degrees north of west. Okay, so that will be a vector. So in physics, this AB, this object here is called a displacement. You connect it with an arrow. That will be the tail, and this is the head. So the notation will be A, B. You see, little arrow, I start from A, I end up in B. This here is a scalar, right? It's a distance. So in physics, distance and displacement are not the same physical quantities. Let me ask you something. If you go from here, you go for a walk, boom, 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 and you go back to the same place. What do you think is the displacement? 0, very good. Okay, but the distance is not 0. So if you go back to the same place, so that will be a typical conceptual question in my class, or if you're taking the MCAT, they like to trick the students, right? Displacement, you connect the beginning to the end. So in one dimension, it's going to be easy. Displacement will be positive if you are moving to the left, negative if positive, I'm dyslexic. Positive if you're moving to the right, negative if you are moving to the left. Okay? Now we're going to define the position, okay, on the number line as a function of time. We're going to define the velocity. So velocity is going to be a vector. It's going to be positive to the right, negative to the left. Speed is going to be a scalar, so don't worry about it yet. Okay, and acceleration also a function of time. So for example, if someone is moving on the number line, let me ask you something. You start your stopwatch at 3. So that will be your initial position. Your final position is at -2. What's going to be your displacement? -5, very good. Or 5 at left. Okay? If you go from 3, you go there and you come back, what's your displacement? 0. But what's going to be your distance if you go from 3 to -2 back to 3? Yes, 10. 5 and 5 is 10. Okay? So, okay, let's try to do this one. It's an easy one. So you have a car. It's the initial position is 10 meters. And then it's going at a speed of 5 meters per second. So it means every second is going 5 meters, right? So what's going to be the final position? 25, very good. Very good, right? So in 3 seconds, it's going to go 15 meters, but it started at 10. So it's going to be 15 plus 10 is 25. Okay, so that's kinematics. That's one equation of kinematics. So if I have like, so let's try to do this one. So no acceleration. The speed, we say it's 5. Initial position is, did we say 10? Okay. So initial position is here. Okay, the time is there. It's about 10. Okay. Resume. Boom, 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 boom. Oof. 25. Do you see? Now, if you look at these graphs here, so just an introduction, this is called graphical analysis. And here you have acceleration versus time. What is the acceleration? 0. It's moving at a constant speed. So every second is going at 5 meters. It's going over 5 meters. What about the speed? Is it a constant or does it change with time? It's a constant. Okay. What about the position? You are moving away from your starting point. So you start at 10. And every second you go 5. 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 So this is position versus time. What is the y-intercept in that case? 10. That will be your initial position. What is the slope? 5. Okay, the slope is 5. You see, run is 2, rise is 10, 10 over 2 is 5. So the slope of position versus time, it's going to be the speed. Not to worry, it's just an introduction, okay? But you can see why they always talk about kinematic equations. So can you help each other and I don't know how to make a screenshot of that, but can you here. Can you find the equation of this line? So that will be math, right? Imagine this is your y and the time. So what's a line? The equation of a line? mx plus b. What is b in that case? 10. What is the slope? 5t. Okay, so that will be one equation of kinematics when you have a constant speed. It's just an introduction, don't panic. Okay. So again, definition, I think you understood well. Displacement is a vector. It's going to be the final position minus the initial position. So if you go from from 3 to negative 5, what's going to be the displacement? Negative 8. Very good, because you are moving to the left. If you go from minus 5 to 3, it's going to be 8. You see? Okay, and this is called a vector. The distance is called a scalar. Okay? So a little bit of... so now, here and there, I put a little bit of calculus. Nothing special. I try to connect to calculus so it will be easier when you have to take calculus. And anyway, it's supposed to be calculus-based. But in 3 dimensions, okay? So in 2 dimensions, you start from here, you go there. Agree? So we call that the initial position or the initial vector position, and that will be the final position. So in 3 dimensions, what we call a vector position, okay, so you have your frame of reference, that will be the origin. So for example, the origin is here, where I put my feet, and the projector over there, that's my point. So I'm going to point at that projector here. That arrow here will be the vector position in 2D or 3D. So it's like saying, whoo, here it is, right? So this is the initial vector position. And then maybe there is a fly over there, boom, 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 and it's going to end up there. That will be the final vector position. Initial, final. Where is your starting point? There, very good. Where is the last point? Over there. So the displacement, you connect this one to that one. That will be your vector displacement in 3D. Okay? It's not too hard. Okay, so for example, you have a fly. Bzzz. That will be your initial position. So the vector position, initial, that will be your final position. And when you connect them together, that's going to be your displacement. Okay, that will be the vector displacement. And if you want to find the coordinates, you will do x2 minus xy, y2 minus y1, z2 minus z1, if it's in 3D. But this is called a vector position. Just say, here it is. Nothing very challenging here. Okay, so that will be the vector position. Okay? Now you can add vectors. Okay? So for example, a force is a vector. So if you have two people pushing, what is it they are pushing? I don't know, they are pushing like a small car. Maybe 10 pounds is not enough, but pushing something. Oh, you're at the gym, right? So you're pushing, and your friend is helping you pushing as well. So 5 pounds and 5 pounds will be 10 pounds. Okay, so you can add vectors in one dimension, you just add the numbers. If someone is pulling me with 5 pounds and someone else is pulling me in the other direction with 5 pounds, 0. Everything happens like I'm not experiencing any force because I don't move, right? So the net force is 0. Or you can say I'm moving 5 blocks to the north, 5 blocks to the south. What's going to be the displacement? 0. Okay, so vectors, you can add vectors. In one dimension, it's easy, just add integers. In 2 dimensions, we'll have to deal with cosine and sine and tangent. It's going to be more challenging. So 5 blocks to the right, 10 blocks to the right, it's going to be 15 blocks. Very good. Okay, or you can say, if you go down 1,000 and or you throw something 1,500 feet and then it's go down 2,000 feet. So what's going to be the displacement vector? Negative 500. Okay, so this is called adding vector. Okay, and then we have a new definition. So we define average speed. And remember, what was at the numerator? Distance. So distance is just the length, right, in meters. But now we define something else, another physical quantity, which is called average velocity. So average velocity, by definition, will be displacement over time, which sometimes doesn't really make sense in the real life, because that means if you run there and then you go back, what's going to be the displacement? 0. So your average velocity will be 5 seconds to do it, but what will be the average velocity? 0, right? When the average speed is not 0, obviously. In the real life, you're not going to say it's 0, but in physics, it's going to be 0.
You stop.
Not, I don't know, it's just the definition. Where do you start? Oh, when you go back, you stop moving. But in that case, it will be, I will show you why. But anyway, average velocity is a vector, it's displacement divided by the time. So we're going to use an arrow here to say it's a vector, and that will be average. Okay? So a velocity is a vector. So in that case, will be positive 25 meters per second because it's moving to the right. And here we're going to say negative 25 meters per second because it's moving to the left. So negative means to the left. Positive means to the right. So a vector has a magnitude, a unit, and a direction. A speed is a scalar, it does not have any direction. Question? Yeah. So x is the position. Okay, so if you go to the number line here, what we're going to call x is the position. So for example, I can say x of 10 seconds, the position after 10 seconds is going to be 3 meters on the number line. But the displacement, the notation is delta x. Delta x is the final position minus the initial position. And sometimes you put a little arrow here to show that it's a vector. So for example, if you go from here to there, you're going to say initial position is 0, final position is -2, the displacement is -2 minus 0, which is -2. Minus means in this direction. Okay?
So for level C.
That would be a vector. But I don't put always an arrow because I don't know how to do it with when I hide with the software. But if you see a delta x, you should know that it's a displacement. If you see a v, usually it's velocity, but it will say velocity, so then you know it's a vector. If you see speed, then you know it's a scalar. I didn't cover everything. Okay, let's do this one. Quickly, we have 3 minutes. This one, it's a race. This one, you see, starting point, finish point. Okay, so it's pointing to the left. It's a vector, and it's going to be negative. Notation is delta x with a little arrow on the top. What's going to be the average velocity? So it will be displacement divided by the time elapsed, right? No, it doesn't come back to the same place. It's just there are two different. Oh yes, you're right. So if it's one run going back and forth, so then the velocity will be 0 because the displacement is 0. Here you're right. So here I'm just asking for this second part here. So it goes from here to there.
Yeah, the problem is just like one direction to nullify the effects of wind.
Yes. So just this run. Just this run. So what do you get? So you divide displacement by the time elapsed, and you get negative 342.7. The point is to show you that there is a negative here because it's moving to the left. So you do final position minus initial position. It's negative. This one is moving to the right, so it's going to be positive. And then if you are an engineer, you know what to do with those numbers. I don't know. Okay? So again, that's going to be in a tutorial we'll finish next week. You have 2 assignments. One is easy, the other one is just to review the math.
For each one. Okay, so they do one because I thought they wanted you to do something after that one. No, they just want to.
Any question? Just divide, right? So remember, this means vector, this means average. So now we're going to have the pop quiz.